Okay, I was asked to do a question, a graphing question from the textbook. So I'm doing, what am I doing? Number 11, page 192, to kind of walk you through the graph of it. Now, first of all, let me just say, I meant to copy it down exactly, but sometimes I just default. I moved the 3 over. It was y plus 3 to minus 3, so I put it like this. It's the same thing. But the trickiest part of this is the b, because this is not this doesn't tell you what the b is, but just by looking at it. Y equals 5 cos. Remember, there's kind of 2 sets of brackets in the default position. So let's factor out that 2. Let's factor out that 2. Factor out from here too, so we can find out what the b is. A, B, C, D. C is positive pi over 2, okay, because the negative is the default kind of position. Pi over 2 is what C is. D is negative 3. Positive pi over 2, negative 3. With the B being 2, that means that the period, 360, or so in degrees, this is in radians, so 2 pi divided by B gives you the period. So 2 pi divided by 2 is pi. Okay, those are the kind of the facts of the matter. What I will always give you guys, I don't want to say always because I'm forgetful and I make mistakes. I will endeavor to always give you guys the graph that you are going to translate. So in this case, it's cos. So I'm going to quickly sketch out cos just so we have an idea of what, like, our baseline. Is that clear? I'm going to do it in pencil so it doesn't take up tons of space, but it might not be super clear. Cos always starts up here, right? This is 1, 1, 2, 3, 4. Sine starts at the origin. Cos starts at 1. So it's going to go from here. And 2 pi is the period for cos of x. It's got an amplitude of 1, so the lowest part is going to be 1. And so it's just a smooth curve. That was terrible. Let me do one other thing before I do this. Should mark our intercepts right in between. So it's going to go through there. I realized as soon as I drew it, I missed the intercept. 1, 2, yeah, and right through there. Okay, better. So I got to hit those. Not super perfect. If I want to go this way, just to make sure I'm getting the whole flow of this bad boy. That was pretty smooth. Okay, this in pencil is y equals cos of x. Now the first things that we should do are stretches and compressions, which is our A. B is responsible for the compression, but the period is what we're most interested in. First of all, it's going up by 5. So where it goes up by 1, now goes up by 5, a factor 5. We're multiplying by 5. So this is 1, 2, 3, 4, 5. It's going to go up here. This high one's going to go up here. If we're going on this side too, this one's going up here. But the low ones also go down by a factor 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. What? 1, 2, 3, 4, 5. Yeah, okay. So it's this long, tall thing, right? That's the A. The B makes the period 2. Here, notice it's 2 pi. One period is 2 pi. It goes through one cycle over the space of 2 pi, which is the same like if it's bottom to bottom here. That's pi, that's pi. It's 2 pi. 2 pi divided by 2 is pi. So now it needs to do that whole thing, but it needs to do that in half the space. So this is going to move here. Okay? This one, half the space, instead of pi over 2. Same with these guys. Now it's just a mirror image. Okay? We can just do the mirror image. So it's over 2. Top one's over 4. 1, 2, 3, 4. So this will give us 2 cycles. The default here is 2 cycles. Now it's going to give us 2 cycles. So now that we have this, we've dealt with our vertical stretch, our horizontal compression. Before I connect the dots, we need to move it over pi over 2 and down 3. So each of these points will go to the right, pi over 2, and down 3. By the way, we can also show where the intercepts are because it's nice and balanced. Right in the middle of these two, of this and this, it's a space of 2, so it's going to go through there. For what it's worth, if you're thinking, man, I need more questions, you can just make up questions, plug them into Desmos for your answer key. You know what I mean? You can check them that way. So each one of these points that I made, now they all have to move to the right, pi over 2, and down 3. Pi over 2 is still pi over 2. It's still like every 2 squares. Okay, it's pi over 2, pi. 3 pi over 2, 4 pi over 2, which is 2 pi. So everything moves to the right, 2 squares, and down 3. Now I'm going to use a different color. I'm going to use red, because this is hopefully the final and the correct and so on. Everything moves to the right, 2, and down 3. 2 squares, and down 3. So this goes here. This one, oh, Lyle, see? That's why I hate using pen. To the right, 2, and down 3. To the right, 2, 1, 2, 3. To the right, 2, 1, 2, 1, 2, 3. To the right, 2, 1, 2, 1, 2, 3, down 3. Okay, I've got the uppermost amplitude. I'll do the bottom 2. Over 2, 1, 2, 3. Over 2, 1, 2, 3. So this is now down 1, 2, 3, 4, 5, 6, 7, 8, which makes sense. Amplitude of 5, going down 3 more. Okay, so I got those. Now I'm going to do my, what were my intercepts. Who's texting me? Tim Taves. Okay, so this goes over 2, 1, 2, down 3, 1, 2, 3. This goes over 2, 1, 2, down 3. Over 2. Oh yeah, over 2, 1, 2, down 3, 1, 2, 3. Something looks wrong. One, 2, 3, 4, 5. Yeah, it's not in the middle anymore. 1, 2, 3. Oh, wait a minute. Three, 4. 1, 2, 3, 4. Oh no, that's right. I'm just missing one. There we go. See, and that's tricky too. One way that I used to teach it this way, and it would get a little confusing, is the first time I would move a dot, I would call it 1. The second time I would call it 2, and then I would like fill it in. That's the final dot, kind of a thing. So you have to kind of figure out your own processes, your own method, and then you just connect these with a smooth curve. And then you can check Desmos to get a real good and clean picture. Hopefully that makes sense for all the steps involved. Let me know if it doesn't.